Okay, today we're looking at Lesson 2-3, Evaluating Functions, which is continuing our discussion of function notation, how we deal with this notation. And we want to understand and evaluate functions. So we have a table below, and I've already talked a little bit about this. The fact that f of x is just another way to write y equals, so that when you plug something in for x, you're really just finding a y value. So you can always think of this as an ordered pair. So when you look at this, f of x, that's really x and y. So it's just a new notation, or it's the same thing, just written in a different way. So here's example 1. We have a graph. So we should be able to read information from a table, table values, a function rule, and a graph. Okay, we've been talking about how a graph is another representation of an algebraic function. So if we have this function defined with this graph, if we want to find function values, remember this isn't x, we're trying to find y. So we look at where x is 4, and then we look across at our y value. So the answer here would be 1. For f of 6, we go to where x is 6, we go up to our graph, and then we look across at the y value. So f of 6 would have a y value of 2. F of 0. Okay, 0 is this point right here, so our function value when x is 0 is 7. Function value when x is 5, it's right here, which is in between 1 and 2. We'll just estimate that at 1.5. Let me erase all those.
There will be a rehearsal meeting for the fall play members.
Okay, the next one.
At this time. Thank you.
For what values of x is f of x equal to 1? So remember, this is a y value. We're trying to find x. So when we look at our graph, here's where y is 1. So we have this point right here. We've got to keep going because there's another place where we have a y value of 1. So then we look down at the x value, and it would be 4. And at about 9.5. Here's another question. Again, looking at the graph. Went too far. It says f of 18. So we're looking for 18. This is a scale of 2. So this is 18, so we're going up, and we're looking across, and the y value is 16. X is 5. So we're going to have to estimate it. It's right about here. So we're estimating this y value. This would be about 3. For what values of x is f of x equal to 4? So now we're given the y value. So where y is 4, we want to figure out what x values does it happen. So that is at x equals 4. We got to look for all of them, and you see that we have another spot here where y is 4, and that also occurs at x equals 12. For what values of x is f of x equal to 16? Again, another y value. So y value of 16 here and here. So we got to locate those x values. That would be at 18. And at 24. All right, domain and range. This is a review question. When we're looking at graphs, we should be able to figure out the domain. So this graph ends, we're looking at the input, which are the x values. So domain stops right here. So our low value is at x equals 0, and our high value is at x equals 26. So our domain would be x is greater than or equal to 0, less than or equal to 26. Or we could write that in interval notation. 0 to 26. And I'm including the endpoints. The range, we're looking at the height or the y values. Our y values go as low as 0 and as high as 20, which we could write 0 to 20 using interval notation. Okay, so this is just another representation of a function. We're using words instead of a graph to represent this function. So we want to write an equation. We're given some information. We're given that at 40 seconds we have 13 gallons of water, and we're going to put the gallons as y because the number of gallons depends on the time. And then we have 60 seconds, 1 minute, and 10 gallons left. Now we're told this is a linear relationship, so if we want to write an equation, we know that this situation has a constant rate of change. That constant rate of change is the slope. So we're going to find the slope. So we'll do change in our y values over change in our x values, and we get 3 over negative 20, so negative 3/20 is our rate of change. And we should expect that to be negative because the amount of water is decreasing. So now to write our equation, our tools, we have slope-intercept form, but we don't know the y-intercept. So I would find it easier to use point slope, which is this. So to use point slope, all we got to fill in is slope, we have, and then use either point to fill in this. And it doesn't matter which one you choose. I'm going to pick this one. So my line would be, or my equation for my line would be y minus 10 equals negative 3 over 20 times x minus 60. So now once we have that equation, we can use that to answer some other questions involving this problem, like in B and C. So it says how many gallons will be left after 20 seconds. So all we do is take this equation up here. Let me go back, because you know what? We were told to use S and G. So S is the X. Remember, this was seconds, this was gallons, and G was my Y. So when I go down here, I want to find G when S is 20. So I take this equation, and I'm going to fill in 20 for S. And I solve this for G. So that will give us negative 40. Negative times negative is a positive. 20 go into there, 2, so I end up with 6. So G will equal 16 gallons. I'm also has to do the same thing, but at 50 seconds. So G minus 10 will equal negative 3 over 20 times 50 minus 60. So again, I'm going to solve this for G. So that'll give me negative 10. Negative times negative will be a positive. So we'll get G minus 10 equals 30 over 20, which will just be 3 halves. So now I need to add 10. And to add that, it's going to turn into 20 over 2. So we'll get 23 over 2 gallons. Okay, the next question, at what time will there be 7 gallons left in the tub? So again, using the same equation, but now I'm going to fill in G with 7. And solve for S, because I'm trying to find the time. So now I do this math, that will give me negative 3. And I can distribute here, so that'll give me negative 3 over 20s plus negative times a negative. 20 will go into 60 3 times, and that will give me a 9. So now I'm going to subtract 9. And now to solve this, I'm going to multiply by the reciprocal. Which would be negative 20 over 3. So the number times the reciprocal gives me 1s, which is what I need to solve. And this will be a positive. 3 goes into 12, 4. 4 times 20 would be 80. And that would be seconds. Think about it. Let's go back up to the beginning. Remember, at 1 minute, we had 10 gallons left, which is 60 seconds. So to have 7 gallons, it should take longer, and it does. We have 80 seconds. So now, part D, find the y-intercept, gallon intercept. What does this number represent in the real world? So, a couple of different ways we could do this. We could take our equation, which is g minus 10 equals negative 3 over 20 s minus 60, and solve this for g. In other words, put it in slope-intercept form. So we'd end up with g minus 10. Okay, so we took this equation and solved for g, and we end up with g equals negative 3 over 20s plus 19. So our y-intercept is 19. It would represent the beginning amount of water in the tub. The other question, C, or E, find the x-intercept. Well, the x-intercept, the time intercept, would be when we put 0 in for g. Okay, so we're putting 0 in for g, and I'm just using this equation where I already have it in slope-intercept form and solving for s. So when we solve that for s, we get 380 over 3, which is approximately 127 seconds. And that would represent the total time it would take for the tub to drain. So if we were to look at this graph, we would have, if we put time in seconds down here, and here we have gallons in the tub we'd be starting at 19, and over here we'd be ending at 127, and the function would be decreasing at a constant rate the whole time. Of course, I can make this graph more accurate if I made a nice little scale, but really I just want you to understand that this y-intercept is the starting amount of gallons. It's decreasing until it's empty, and it takes approximately 127 seconds to complete that. All right, so this completes this introduction. Tomorrow in class, we'll do some practice with reading function graphs, making sure we understand that, and we'll practice some of these word problems, taking the information, writing the equation, and we will focus on linear functions, and then interpreting that information.